Good morning, Trig. I almost said Algebra 2. Good morning, Trig. We are going to do a quick review on parabolas and how to graph them. This is review from Algebra 2. So, parabolas. Parabola is the name of the graph for a quadratic equation. Okay. The parent function is just the x values squared. So -3 squared is 9, -2 squared is 4, -1 squared is 1, 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Now this table can be built infinitely, but I wanted to show you the parent function. So here's 8, 6, 4, 2. And I also want to show you how I graph it because it'll save you some time later. So I do it without the use of a table. So let's cover up the table. I know the value of x is squared, and I know the graph should be U-shaped. So I'm going to start right here at x equals 0, okay? Now, if x equals 0, I'm now plugging it in my mind. Okay, 0 squared is 0, so that point is 0, 0. Okay, next point. If x is 1, so I'm going to go over to 1. And in my head, what is 1 squared? Well, if I square 1, I get 1. Now, this method works anytime a is 1, so there's no number out here. Okay, if x is 2, so go over to 2, and then ask yourself, what is x squared? So what is 2 squared? 4. So if x is 2, y is 4. Go back. Now I'm going to x is 3. When x is 3, y should be 9. Now, I know this is a parabola, so I know it should be U-shaped, so I should have a nice curve here. I also know that a parabola is symmetrical, and right through here is called the axis of symmetry. I put AOS, and so here, for example, this would be at x equals 0 because my vertex is at 0, 0. So if this is symmetrical, this point here is 1 unit to the left. This is 2 units from the axis of symmetry. This is 3 units. And so there is the left side. Okay. Now a couple of things to review. If the number out front is a negative, then this makes the graph open downward or point down, however you'd like to think of it, but it's also a reflection across x. It's called all kinds of things, but it will force the parabola to point down. Now, vertex form is the form we're going to use today. It looks like this, and when something is in vertex form, my vertex is h, k, and so we're going to use these points today. So in this section in 54, there is no point A or point B. We are going to graph by completing the square. Now we haven't gone over completing the square in a while, so I will review it again today. So number 1. The first one we're going to do is y equals x squared minus 4x plus 2. So to complete this square, I'm going to do a couple things. I'm going to leave a space on the left and the right, but I am going to find, you take the middle term, you divide it by 2, and you square it, and you add to both sides. So my b term in this case, if it helps, there's an invisible 1 here. So that's a. -4 is b, and 2 is c. Okay, so that is review of A, B, C. So I'm going to take a value of -4 divided by 2 and square it. That gives me -2 squared, which equals 4. So I'm going to write what I had before, x squared minus 4x. Notice I left a space on the left and a space inside because I'm going to complete the square. That's a 4, so I'm adding 4 here, and I'm adding 4 here. Okay? Now, I'm going to do a couple things at once. I'm going to subtract the 4, and I'm going to factor my parentheses. So I'm going to rewrite my parentheses. So I have y equals, I'm going to factor this. This should have perfect factors, which are x minus 2 squared, and then 2 minus 4 is negative 2. So this is what I am factoring, or sorry, this is the form I'm going to graph it in. Okay, so my vertex is at 2, negative 2. My a value is a positive 1, so I know it points upward. And so we are going, where's my ruler, to graph it. So here's x, here's y. My vertex is at 2, negative 2. Now we're going to use the same method from earlier, but starting at our vertex. If x is 1, 1 squared is 1. If x is 2, so go 2 to the right, 2 squared is 4. Now this works because a is an invisible 1. Or you could build a little table on the side and plug in a couple values. So I'm plugging in, this would be 3, and I'm plugging in 4. If I plug 3 in, right, I'm using this. 3 minus 2 is 1. 1 squared is 1. 1 minus 2 is negative 1. Plug in 4. 4 take away 2 is 2. 2 squared is 4. 4 minus 2 is 2. And guess what? That should match the points I found using my method. So, to the left 1, 1 squared is 1. To the left 2, 2 squared is 4. And so here is your parabola. Now, if you use this method, I plot the points to the right, and I use my axis of symmetry should go right through the vertex, and each point should be the same distance from that axis of symmetry. So we're going to do 2 more, and that will complete this section. So a lot of review in this section. So number 2, y equals negative x squared minus 6x minus 8. So let's go over how to complete the square. First, I have to factor out the negative 1. And when completing the square, a can be nothing but positive. So now I'm left with x squared plus 6x plus 8. Sorry. I'm going to leave the minus 8. I'm only factoring negative 1 out of the first 2 terms. And my brain, sorry, this is the last video of the day. My brain is, phew. All right, then I have to figure out my middle term is b, so 6 divided by 2 squared. That would be 3 squared, which equals 9. So I'm adding 9 here, and I'm adding 9 here. I have to add it to both to make it make the equal sign true. Now when I go to write this, and I'll keep it like that so you can see. So I have y plus 9 equals negative 1. I'm now going to factor, right? I have 9 and 6, so factors of 9 would be 3. So x plus 3 squared minus 8. Now if I want to get this in vertex form, I have to then subtract 9. So in vertex form, I have negative x plus 3 squared minus 17. Now I feel like I've messed up, and I did. I'm just moving along so fast. So let me cover a couple of things. This is a positive 9 on the inside, but technically I took a negative 1 out of it. So negative 1 times 9, I'm actually subtracting 9. So I have y minus 9 because technically this is a negative 9. Now, I would then have to add 9 to both sides, so this is a positive 1. I am so sorry. So let's go over a couple things. Let's talk about our vertex. Should be opposite of what's on the inside and the 1. A is a negative 1, so my graph points down because that is negative. So, using this, I have, here is my graph. Now, notice I left room on the left because my vertex is negative. So I have a vertex at negative 3, 1. Now it points down. So if you would like, you can build a table. So this is at negative 3. I'm going to plug in, it doesn't matter which, I'm going to plug in negative 2 and negative 1. I'm not going to plug in 0. So I would have negative 2 plus 3 squared plus 1. Right, so that would give me negative 1 squared plus 1. That would give me 0. Now, you could use my method. If x is 1, 1 squared is 1. And I'm going down because I know it points down. Go back to the vertex. If x is 2, 2 squared would be 4. But let's check it. Negative 1 plus 3 squared plus 1. That would be negative 2 squared plus 1. That would be negative 3. And yep, right where I thought it would be. Here is my axis of symmetry, meaning your graph should be symmetrical. So this value would be here, and this value would be here. You could also graph this on Desmos and check your work there. Okay, next one, or last one. So y plus x squared equals negative 8x minus 10. Woo! All right, so first let's rearrange this to be y equals negative x squared minus 8x minus 10. I'm going to rewrite this, right? I'm going to take a negative out of x squared and the negative 8x, but I'm going to leave minus 10 on the outside. Okay, so I took a negative out of here and here. Then I have to do the 8 divided by 2 squared, which leaves me with 4 squared, which is 16. So I'm adding 16 here, but I'm subtracting 16 here because that negative has been taken out. So I have y minus 16 equals negative x plus 4 squared minus 10, and then I would add 16. So y equals a negative x plus 4 squared plus 6. So my vertex is at negative 4 and 6. And a is a negative 1, so again my graph will point down. So this graph will be a little bit higher up on our y-axis. So 2, 4, 6, negative 2, negative 4, negative 6. So negative 4, 6. Now a is still 1, so I can use my method. If I go over 1, I'm down 1, over 2, down 4. Or you can build a table picking numbers. If this is at negative 4, I'm picking negative 3, and I'm going to pick negative 2. If I plug negative 3 in, I get 5. If I plug negative 2 in, I get 2. And then, using the axis of symmetry, I'm reflecting each point across. And that is our graph. And that really covers that section. For homework, we're only going to skip number 5 and 24 through 26. If you come across any problems from lesson 53, you're going to want to use my notes and worksheet for lesson 53. But that completes lesson 54. Thank you.